Looks like Ruben is somewhere.
All right, then let's get started. Can you all hear me? Yeah, can you hear me? Anything? Yes. Okay, good. I'm glad we're back. I went ahead and moved back so that I'm away from some people so I don't disturb them. Okay, so today I want to do something a little different. I want to keep talking about abstraction, um, but I want to look at abstraction from a different perspective. So let's say, for example, that we write a program that takes in your birth date, okay, and outputs your age. Okay, this is not a hard program to write. So I want you to think and tell me what kind of information you would need to store to be able to do that. What year is it? Absolutely. So you actually need to know what the year is right now. So it's what, 2017? That's good. What else do you need to know? How many months are in a year? Maybe. Okay. Current year number of months in a year. Oh, I see. So you're talking about like it happens to be September. Is that what you mean? Days in a year, maybe. Um, what really, what really do you need to know to figure out what somebody's age is? Am I? Sorry about that. Um, I actually got a warning that my connection is unstable. I guess I gave them too much credit. Um, right. Okay. So I'm going to go with Jacob's answer because that's 100% correct, and it covers what I want to talk about. Actually, it does a bit more than that. So we need to know how long ago the date was from the current date. Yeah. Okay. That's exactly. Leap year. You know, things get hard, right? You know, you're exactly 1 year old or 4 year olds. Dallas gives a really nice summary. The birthday and the current date and the birthday. Joel got it at the same time. I tend to agree with that. Okay, that's the fundamental information that you need. Okay, so so that's the exercise. Okay, so I'm trying to get at this idea of what do you need to know to be able to do your program. Okay, let's try a different one. Okay. Let's say that we're going to write a program that computes your grade point average. What do we need to know? how many classes you have and your grades in each of them. Grade letters for each class, total number of classes. Number of grades, numerical value for each grade. Okay, very good. I'm a silhouette because my camera isn't smart enough to focus on me and not my background, which is very bright. Okay, could be better. How to find the average? I actually want to address that. Okay, so what I mean when I'm asking these questions is not about what algorithm we're going to use, what method for doing the computation. It is simply about what data do we need to do it. Does that make sense? You see the difference? Right? If you know how to find an average, then you can actually compute anybody's GPA, right? All you need to know is the specific grades each person has, right? So that's the thing that I'm interested in. Okay. All right. Now let me ask you about things that don't matter. What doesn't matter in a program that's trying to find your GPA? What school you go to? Very good, right? That's totally irrelevant. Okay. What else? Letter grade. I think I need to know the letter grades, right? You know, 3 A's and 2 B's. Your name, your age, sex, how hard you tried. Oh, truer words were never spoken. Isn't that a sad? Okay. The name of the class? Absolutely. Teacher qualifications. Ooh, somebody's getting mean. Okay, fine. Number of words per minute. Okay. I'm not entirely sure what that's in there, but that's true. I don't need to know that. Okay. So again, there's a lot of things we don't need to know. There's some things that are critical. Okay. That is chemistry. Sorry, it's a rite of passage. Um, I don't need to know that. Thank you. But the whole point is that some things are important. Those are details that we need to know. Something else are things that we don't need to know, so we set them apart, right? Diameter of the sun. I'm coming back to that later in this lecture. You're reading my mind. But it's the process of separating what's relevant from what's not relevant that that is abstraction. Okay, so that's why I wanted to talk about it in this context. Okay, now you guys are actually, I think you guys got this pretty well, so I'm not going to dwell on that. Instead, I'm going to try to share my screen, and hopefully I don't crash my computer. Okay, because like I said, I'm in a unstable wireless network. But let's give it a shot. If it does crash, I'll dial in a few minutes. Okay. Okay, looks like we're still here. So I want you to take a look at this program. I'll just start running it, and I'm going to talk about it. Okay. So I want to make sure I can see the chat somewhere. All right. I actually can't tell where it is. So here's what I'm going to do. In case that I start going out and you can hear what I'm saying, one of you who has a webcam, just kind of wave at me so that I know, okay? Because I can't see your feedback on chat. But I want you to take a look at this program that I have right here. You can see a big yellow circle and something happening inside. I'll start it off again. Okay, so this is kind of what I want you to try to run. And here's what's happening. I'm going to talk to you about something that's actually true, physics. Okay, and then I'll talk about the process of abstraction. And here's what's happening. Everything that comes out of the sun, all the great energy that actually powers, well, us, right? Starts at the center. Relatively small region of the center where you have hydrogen atoms colliding, and actually they're not really atoms because they picked off the
for PC now.
electrons, right? So they're just two protons that collide and create helium atom. Actually, it's not even that simple. There's kind of a multi-step process that happens. As part of that step process, then you get this very high energetic bits of radiation, or photons, if you will, exiting, okay? And it takes, roughly speaking, 8 minutes for a photon to get from the surface of the Earth, I'm sorry, from the surface of the sun to the Earth. That's not a lot of time. That's a big distance. Speed of light is very large in a vacuum. But here's what actually happens inside the sun. Oh, will you look at that? Yay. Okay, now inside the sun, what happens is that the photon is emitted from the center, and almost immediately, because the sun is so dense, it actually hits some kind of a particle, let's say a proton, and it bounces off, okay? Then it goes in a different direction. And guess what? It hits another particle, right? Because the sun is so dense. And so it has to turn around, go another direction.
Yes.
And eventually, and think we're close here, eventually it, boom, hits the surface and it comes straight to us, okay? So it really takes only what, 8 minutes once it reaches the surface, but it can take considerably longer to get to the edge, okay? So that's the science background. Do you guys think you have a kind of an idea as to what's happening that in the science? Okay, and did you guys think you followed the science reasonably well? You're talking just photons, move in a direction, hit a proton or an electron, bounce, hit another one, bounce, hit another one, bounce, right? And eventually they get to the edge, okay? So here's the question. How long does it take a photon to get to the edge of the sun from the center, okay? Right? QED, very true. Okay? Right? I don't expect anyone to have the answer. My guess is that it takes a lot longer than what you could claim if you were just guessing, okay? But now I'm gonna talk about abstraction, okay? And I want you to kind of see this process of abstraction. First of all, you see this yellow circle, right? You see that? Okay, it's just disappeared, but here we are making it again. You see that yellow circle? That is the sun, okay? Talk about abstraction, right? I mean, the sun is this great, incredible cloud of plasma that is fusing hydrogen in the center, goes through all sorts of convection mechanisms, and then eventually lets light out into the earth. We've just condensed it to a yellow circle, okay? Because we decided that that was the only thing that was relevant. The claim that I'm making, right, is that what's really relevant is the distance between the center and the edge of the sun. That's all that matters, okay? So you see, there's the process of abstraction. What do I not have? I don't have the fusion process that makes the atoms come and stick together and generate energy. There's no nuclear physics here, okay? It's just the sun. Yeah, that's 100 units wide, okay? Now here, now you can kind of start seeing what's going on there. That's the turtle moving, right? And it moves in a given direction for a given length. And then it turns and it goes into a different direction, okay? That kind of captures what we need to know, okay? In order to answer the question, how long does it take to get from the center to the edge? I'm simulating the path of a photon by saying, well, I go off in that direction. Oops, I hit something. Now I go off in a random other direction, okay? My program makes a few, shall we say, simplifications, okay? First simplification the distance that the photon travels is always the same. Okay, so it always travels by, can't even remember, but let's say one step. Okay, we say move one step. Who can tell me why that is absolutely completely wrong? Okay, about the sun, for example. You don't get anything except the recognition of your peers, I'm sorry to say. Maybe at some point I'll figure out how to send candy or stars or something to make this more fun. But for now, just for recognition. Gold stars, that's what we need, yeah. You can't walk on the sun. Okay, I've been using the word walk. It's a photon, right? You can't actually move in the sun. Teleport, okay, I'll try. Okay, I'm thinking really hard. It's just not working. You say the distance between the particles isn't consistent. Okay, that's true, but why exactly does that matter in the sun? What is one property of the sun that we're just ignoring completely? I'm wrong in many ways. I don't know which one exactly. Density, very good, right? The center of the sun is very dense, right? That means there's a lot of particles per unit volume. So it's going to run into particles a lot. When it gets closer to the edge, it's not as dense, right? And so it should actually be hitting particles a lot less. So the distance should get longer when I come close to the edge than when I'm in the center. Guess what? We are ignoring it, okay? Gravity doesn't really affect it. Gravity actually changes the color of the light, but it doesn't affect that particular thing. Unless what you mean is that gravity affects the density of the sun, in which case you are right, okay? All right, so here's something that we just decided to ignore. We decided to ignore density, okay? By we, I mean I decided to do that. And I'm taking the credit because it's actually blame, okay? My model is not a very good model, but it's one that we can write, so we're gonna run with it, okay? So that's part of what we have, okay? We're ignoring density. There's something else that we're ignoring that's a lot more subtle. Why is the sun not a circle? The sun is not a circle. Surely you guys can give me some reasons to believe that. Okay, so first of all, it's a spheroid. That's right, it's not quite a sphere because of rotation. That's the kind of thing that I could reasonably ignore, okay? And just say, hey, you know what? It's close enough for government work, okay? Absolutely, they're formed under gravity. That makes them a circle. I'm sorry, a sphere. Rotation makes them not a perfect sphere. Very good. You guys are really good in your science. I'm happy to see that. Okay. But you nailed it, and that is that the sun is not 2D. The sun is actually 3D. Okay, right? So we're going to do 2D. Why? Because Snap Turtle is a 2D turtle. It's not a 3D turtle. Okay. But I hope you didn't. But anyway, what was I going to say? Maybe the answer changes if you go from 2D to 3D, okay? I'm going to, not that I know of, I don't know any 3D turtles, but if you wanted to do this in 3D, you could, you just couldn't have the visualization, okay? You'd actually have to just do the work. And what I would ask you is this. I want you to build a copy of this program that you're seeing run in front of you, okay? And get the answer for 2D. All right. If you want, and this is an if, you do not have to. This is not a assignment, so to speak. Okay. But what I will do is, if you solve this problem in 3D using Snap, okay, without the graphics, you just do the simulation and then show me your work. I will count that as any 3 future projects of your choice. Okay. So you know, if you do it, then come back and say, hey, I did it in 3 dimensions and it gives the same answer. or I did it in 3 dimensions and it does not give the same answer, whichever one it is, and I'll let you figure it out, okay? And to reward you for that, I will say you have shown enough computer knowledge that I can just assume that there's 3 other projects you would have done well anyway, okay? So that's how I would give you credit for that. Can you make every particle in the star? Good luck, okay? There's just too many. And so you wouldn't even be able to put them into the computer, right? So let me be extremely clear. In fact, I'll put up a note here. Boy, that worked great. Here it is. I don't think you have enough computers in the planet to be able to model every particle in the sun, okay? But what you can do is this. Build a circle and repeat many times. Start in the middle of the circle. Pen down. I'm just saying that because I always forget that, and then I feel like an idiot when the thing moves and it doesn't leave a trail, okay? Move in a random direction, a fixed number of steps. So you pick how many steps you want. Try not to pick something that will get you out of the sun in 1 step, right? So if your sun has radius 100, maybe you can do something like the number of steps is 5, right? So it would take at least 20 steps if you get really lucky to get to the edge. That's it, okay? I guess the only other thing that I want to say is keep track of the number of steps. And what I mean by that last statement is this. Right here, I put the radius of the star. That's actually not important. This just lets me change it. But the number of steps, that says 2,440 right now, okay? So you can actually tell how long it took to get to the edge. Now, what I do is I just keep doing it over and over and over and over, and I keep track of the average number of steps. So in the beginning, these 2 are equal, right? But after I run this 2 times, then it could be that one time it took 3,000 steps, the next time 10,000 steps. So on average is about, I don't know, 6,500 steps, okay? And it just keeps doing that so that I see eventually, oh, it's about 7,000, okay? So anyway, so that's what I want you to build. Any questions about that, okay? How do you make a circle efficiently? Oh, that's 2 different questions, okay? So first question, how do you make a circle? Remember that on a previous unit lab, I asked you to build a polygon, right? That was actually the same program that did the squirrels, right? That polygon, if you simply call it and say, I want you to have 1,000, sided polygon, you don't even need 1,000, 500, even 100. It looks like a circle. That's good enough. When is it due? Nothing that I say is due in less than a week, okay? So I'll just set it up for next week. But honestly, I'm taking us out of the curriculum for a little bit, okay? Because I wanted us to do something that was more fun before we hit the next bit of the curriculum, okay? And I guess I'm a nerd, but I happen to find photons and suns and random walks to be fun, okay? So that's why I gave you this project. Okay. All right. Why don't you, well, again, more questions? What I'm doing, that's actually, for those of you who haven't signed up for the class, um, I actually haven't graded the previous assignments, and I will not go this long without grading once we get the course going. But the reason that I haven't is because I want to be able to grade all of you at the same time. And I'm waiting for those last few stragglers to join the class officially, okay? So, so that's why, okay? Um, and as far as the coding in the future, I'm probably not going to do C#, but I'm very likely to do Python later, okay? And I don't want to tackle it first because there's actually some things that I want to do with this this stuff before we head to a Python. If you absolutely insist, talk to me outside of class, okay? And I'll help you by giving you some Python programs that you can write, and we can make that work. I'm actually teaching a second course on Python for data science, so I have some projects there that are kind of interesting, and I'm willing to share those with you, and we'll negotiate what that means as far as grading, okay? And I mean negotiate. So I want you to bring some ideas and say, this is what I think would be fair. And we'll go from there. Okay? And don't worry about speaking up and asking for stuff. Okay? It's perfectly fine. All right. I'm going to pause the recording so that folks don't have to watch me watch you while you're doing work on this. I will be looking at the chat. Interrupt me if you see anything, and I'm going to mute myself because, like I said, I'm in a public space, and the other people aren't paying for the class, so they shouldn't get the benefit, right? Okay, so I shall try to figure out how to change this.